In this class, we are going to look at sets. So what is set? Set is a collection of objects. So if set is a collection of objects, what is set theory? Set theory is the studying of the collection of objects. The collection of objects is the foundation of discrete mathematics. Okay, so the next thing I want to ask you now, if we say set is a collection of objects, what is the meaning of object? Object means numbers, things, places, etc. But you need to also go further to define the type of object you are talking about. When we say object, we are talking about well-defined object, well-defined object. If the object is not well-defined, we cannot consider it what as an object. For example, you are looking for something in the house. Let's assume that this house, there are how many rooms? This is room 1, this is room 2, and you come to this place. Let's assume there's somebody here that's a gatekeeper, and you are looking for something. And you ask this guy, I'm looking for something. Let's say you are looking for a spoon. The person tells you that what is in the room. In the room. If the person tells you that what is in room 2, this one is more what? Precise. This is better what? To define set. So both of them are correct. This is correct, this is correct. But this is more what? Precise. So this is preferable in set. When you can define the object precisely, then we can use it as what? Object of a set. Assume that this is set Z, and this Z has element Z1, Z2, Z3. This set is denoted by what? A capital letter. The collection is defined by what? Small letters. Therefore, we can say Z is equal to, using curly bracket, not curved bracket, not square bracket, curly bracket. So all these are known as what? Elements of a set. Z is a set. These are the elements of the set. We use this one first before we put the element in between the curly brackets. So this Z1, which is element of Z, we can write it like this. Z1 is element of Z. Okay? Assume you are working in a company. You are here, and your company, let's say company, has many people that are working with it. And you are here. Let's call you A. We can say A is element of the company. Okay? This is small letter. This now you see is capital letter. Now let's look at example of some set. For instance, you know what is natural numbers? That is from 1 to infinity. These are what elements of a natural number. Natural number n, these are the elements of this word natural number. What of things like prime number? You agree with me that prime numbers are this set of numbers 2, 3, 5, 7, 11. So these are the elements of what? Prime number. Let's say P. You agree with me that Malaysia is in Asia. China is part of Asia. Hong Kong is part of Asia. All these are elements of what? Asia. Remember we said what? Places. Numbers, things, places. For instance, A, B, C, D, E to Z, they are all elements of what? Alphabet. What about real numbers? Real numbers start from where? Start from negative infinity to positive infinity. All these are what? Elements of what? Real numbers. You have 5 children and you are part of the family too. Your wife is also part of the family. You can say what? You, your wife, your 3 children are elements of a family. Let's say your family name is the Peters family. These are elements of what? The Peters family. Okay? And so on and so forth. All this is understood. Universal set versus subset. What is the difference? This symbol is used to represent what? Universal set. For instance, all the countries in Asia, and you agree with me that China, India, Malaysia, you will find them where? In Asia. Why is this important? Maybe, for instance, you have a study you want to do for all the country in Asia, because these are the countries under consideration. We say this is what the universal set. You agree with me, China, India, Malaysia, they are part of the study. They are part of the countries you are studying. Because this A is part of this, we say what? A is a subset of this universal set. How do you represent that? Say A is a subset of this. Okay? A is a subset of this universal set. Assume you have this. Say B is equal to. Assume these are the only objects, the elements I want to study. I don't want to study any other elements. These are the data I've collected. This could represent what? My universal set. I say B is a universal set. But now I want to take prime numbers from this B. Let me call the prime number P. And the prime numbers, you agree with me, they are 2, 3, 5, 7. And you agree with me that 2 is here, 3 is here, but 5 is not here, 7 is here. Let me go for another one. Say T is equal to 2, 4, 9. You also agree with me that 2 is here, 4 is here, 9 is here. Because everything in T, you also find them in B. We say what? T is a subset of B. Proper and improper subset. If I write this, I'm either say proper or improper. If I write this, I'm say what? This is what? Proper. 100% sure. As you can see, all the elements in this place are also here. But not all the elements here are here because of this 5. Because this guy has his elements from this place, we say T is a subset of B. T is a subset of B. How do you represent this? Say T is a subset of B. As you can see, it is 100% subset. That is, this word subset means less than. T is 100% less than B. We say what? Is a proper subset. Proper. Okay? Proper. The way it should be. Before I can call you subset, that means all your elements must come from me. But before I can call you proper subset, I'm very sure that everything in you are from me. Okay? Therefore, we say what? T is a proper subset of B. Proper. No issue. But if I write something like this now, I come back to this place. I say I have another one I want to consider. This time Z. I say Z has 1, it has 2, it has 3, it has 4, it has 7, it has 9. You agree with me that everything in Z is also where? In B. Oh, how do we represent this? It should be a subset. Subset means that you are less than. But you cannot tell me that this Z is less than B. It's not actually less than. They are equal. But how do we describe this? We have to still use the word subset. You agree with me that the meaning of subset is that everything here actually comes from this place. Qualifies to be called what? Z is a subset of B. What type of subset is this? Is it proper or improper? It's improper. Although you want to be my subset, you should not collect all my elements. That is improper. You just take everything from me. To take everything from me is improper. It's improper. You think of it. We say what? Z is improper subset. Improper. It is not okay. It shouldn't be like that. Though you are a subset, but the types of subset you are is improper subset. Therefore, we say Z is improper subset of what? B. Why this? That means you can say this one is less than or equal. less than or equal. Not 100% less than. Not 100% subset. But what is less than? You can call this one less than or equal to. But invariably, Z is equal to B. B is equal to Z. To represent this, the only way to say what Z is improper subset of B. Improper. Though you are a subset, all your element comes from me, but I don't like what you have done. It is improper to do what you have done. Also, you can say B is improper subset of B. Of course, everything in B are also in B. Is improper subset. You cannot actually say they are subset. To say something is 100% subset, it is called a proper subset. That is, you are properly less than. So from here, we can say what T is 100% less than B. T is 100% less than B. That is proper. Proper. This is proper. What we have done is proper because this guy called T took few elements from B, not all. That is proper to do. Are you getting the difference now? Okay, good. Sometimes, if I say, for instance, K is equals to A, B, C, D, E. Okay? I say J is equal to C, D. You agree with me that J is a proper subset of K. Proper. No issue. If you want to write it like this the other way around, remember these two sides must face K now. It's like you do J is less than K or K is greater than J. But we don't use this language in set. We use subset or superset. We can say that K is a superset of J. Or we say K contains J. Because all the elements in J are found in K. K contains J. Or K is a superset of J. Superset. Now let me come back to this place. What was the purpose of this? Not to confuse you. Because all the elements here are not from here, we can say what? P is not a subset of B. Can also do it like this. This, not this. Pair B, we write it like this. What? Not a subset. Not a proper subset. Not a subset of what? Of B. Either way you are correct. Because not is not. You are not, you are not. But invariably, the best way to write that is all the time. Something Q is not a subset of Z. Something like this. All the time. Not actually this. You now know the difference now. We have treated so many things now. We said the first one, if we have the numbers we are considering for these studies, like this, and we have a set we generated from this place, let's say 3, 10, and 7. We say actually, sorry, here let's put this place 12. We say B is a proper subset of what? A. Proper subset. We also said, we can say A contains B. Or A is a superset of B. Then we said, if you want to describe B versus B now, B versus B, we say B is improper subset because you can say they are equal, which is, you can also say they are less. It's still okay. That word is okay. Though in your mind now, you don't believe, how can you be less than when you are equal already? Because this is the guy we are considering. If I happen to get another guy from here now, for instance, let's say K is equals to same 3, 10, 7. Definitely, K is improper subset of B. Don't think because I write BB here, you are not confused. No, that should not confuse you. The point still remains that two of them are what? Improper of themselves. When you are describing a set against itself, it is improper to do like that. It is improper to do such. Improper. So don't forget, you must still use this word improper when they are equal. So if you put all these values in B in K, let's say this is a variable, this is a variable, we put all the values in B and K, definitely we can describe them like this, that what? They are improper subset of each other. And we also said that if you have another set whose elements are not here, we say what is not a subset of this. All this is understood. Thank you for viewing. Singlet sets. What is that? Single. It means we have a single element in that set. For instance, there is a country called United States. You agree with me, right? How many presidents do they have? Just one president. This kind of set is called what? Singlet set. You have a university. And this university, each point in time has just one what? VC. One VC. Vice Chancellor. A country, just one president. These are called singlet sets. Or in a secondary school, you agree with me, we only have one principal per time. Such is called what? Singlet set. Hope this is understood. Thank you for viewing. Null or empty set. It means this set has no element, contains no element. We denote it as this. This is used to represent what? An empty set. Or empty curly bracket without anything. For instance, in Python, you want to define an empty set, you don't put anything in between. Or you want to define an empty list, for instance. You do this, right? You say, for instance, A is equal to this, or you say B is equal to this. You are actually defining here an empty list. I'm digressing anyway. But if you do anything like this, you are defining what? An empty set. That means this particular set has no element in it. And it is a subset of every set. How do I mean? Any set in this world, whether it's single thing, whether it's a universal set. For instance, I say A is equals to 1, 4, 7. The empty set or null set is a subset of this. It's a subset of A, because 0 is actually less than A. If you want to put it in the language of what? Inequality. So it's what? A proper subset of A. So null or empty set is always what? A proper subset of every set. But what I want to explain to you before I leave this place, if you do something like this, this is no longer what? An empty set, because it has one element. 0 is not a non-existing number. It exists. Okay? Take note of this. Hope this is understood. Thank you for viewing. Superset. What is the meaning of superset? A superset is a collection of all the subset of a given set. What is that? That is, if you are given a particular set, how many subsets can you derive from that set? So the collection of all these is called what? Superset. Let me give you some examples. Say for instance, you are given this set. You are given this set A. This set has one element. How many subsets can you derive from this? Remember, a null set is a subset of every set. That is the first one I can get from it. Another combination will be just A. Remember, I can donate this like this. Empty and A. How many? 2. So this is called what? The superset of this. P. Or for instance, if this was A, I can say what? P. A is equals to all this. An empty set. Okay? This is called what? Power set. And look at it very well. It simply means 2 raised to power the number of elements in that set. And the number of elements here is 1. This is 2. How many set? 1, 2. Let's continue. You are given this set. Say K is equal to A and B. How many subsets can you actually derive from this? You simply say what? 2 raised to power the number of elements in this place. You can derive what? 4 different kind of what? Subset. Remember, the first one is always what? The empty set. You can take only A. You can do only for B. You can still do for AB in proper subset. How many? 1, 2, 3, 4. So P, K, or you say P, A, B, is equal to this. This is called what? The power set. Let me say continue. For instance, you say M is equal to 1, 2, 3. You are asked to find the power set of this. 2 raised to power 3, which is equal to 8. That means 8 possible subsets we can derive from this place. Let's start. The power set of M is equal to, the first one still remains the same. 1 can be alone, 2 can be alone, 3 can be alone, 1 and 2 can be alone, 2 and 3 can be alone too. 1 and 3 can also be together. 1, 2, 3 can also come from here. How many? 1, 2, 3, 4, 5, 6, 7, 8. These are the power set of M. Hope this is understood. Thank you for viewing. Equal set. What is equal set? For instance, X is equal to A, B, C, D, E, and Y is equal to A, B, C, D, E. We say S is equal to Y. That is, they contain the same elements. The same elements. What about equivalence set? If I have, for instance, K is equals to A, B, C, D, and I also have N is equals to 1, 2, 3, 4. Although they don't have the same elements, but they have equal numbers of elements. How many elements are here? 1, 2, 3, 4. How many are here? 1, 2, 3, 4. Therefore, we say K is equivalent to what? N. For this one, it is exactly the same element. We say they are equal. You can also say S is equivalent to Y. But you can't say that what? K is equal to N. It's not possible. You can only say what they are equivalent. This is the difference between equal set and equivalent set. Hope this is understood. Thank you for viewing. Set builder notation. What is set builder notation? This you are seeing here now, curly bracket X slash S less than 0, then curly bracket. This is a notation for a particular set. We already know that this curly bracket is used for set. What is the meaning of this first X? This represents all the elements of the set we are describing with this notation. Okay? This one means such that. Okay? This place is for what? The condition. For the conditions. When I say conditions, what do I mean? That is, this is a place that will tell us more about these guys. This place, after this slash, will tell us more about this X. If I want to build the set this notation represents, I will do it like this. X, and S means anything less than 0. Okay, that is to say, -1, -2, -3, -4, and so on and so forth. By looking at this notation, I was able to build this. Also, you can look at a set and build the notation. Let's see. For instance, you are given something like this. You are asked to get the notation for this set. What would you do? To get the notation, I will say X. What are these numbers? These numbers are what? They are natural numbers. I will say what? S is element of what? Natural numbers. That is this side. These guys, they are parts of natural numbers. This other side, I will use it to describe this more. I can see that it started from where? From 4, then to infinity. That means this S is always greater than what? 3. Such that X is greater than 3. Or I will say such that S is greater than or equal to 4. You can do it like this. This notation is telling us more about these guys. What if I had this type of set? I will see right S is element of what? Natural number, such that this is 4 and 9. S in between. S is less than or equal to 9, greater than or equal, then I cover it. You see, this notation is representing this set. That is all. If you are given any set, you can derive a notation from it. If I give you something like this now, I say, okay, this time N is element of K such that N is greater than 7. I said, okay, build the set from this place. Okay, N is element of K such that N is greater than 7. To build this type now, I will simply say what? 8, 9, 10, 11, and so on and so forth. You are given this. Get the set builder notation from here. You simply say N, you can put any letter, is element of what? Real numbers, such that N is greater than 1 and N is less than 9. Okay? You can do it like this. You can even do it like this. N is element of real numbers such that N is greater than or equal to 2 and N is less than or equal to 8. As long as if you look at this, you can still build this guy back, you are okay. This can build this back, this can also build this back. You can use this one to reconstruct this. You can also use this guy to reconstruct this. This is what? The set notation of this set. What is cardinality of a set? It is the number of distinct elements in a set. For instance, this is a set with this element. So we have, let's say P is equal to this. So the cardinality of P is represented as this. Is equal to how many distinct elements are here? 3. Let's say we have X is equals to 4, 6, 4, 9. How many distinct elements are here? As you can see, this and this are the same. So we are going to take them as one. This 2, then 3. So the cardinality of set X is equals to 3. Okay? So it must be distinct what? Elements. Let's see more examples. For instance, if I say U is equals to A, so the cardinality of U is equal to 1. And if I say M is equal to 6, 6, 6, 6, 6, the cardinality of M is equal to 1. Hope this is understood. Thank you for viewing. Set operations. Let's look at set operations. The first thing we must put at the back of our mind is, if we have a set, say X is equal to 1, 2, 3, 4, all these are called what? The elements of a set, and it's represented as this. Can say 1 is element of X, or we say 2 is element of what? X. So the first thing we are looking at now is what? The element of a set what? Okay. So if I give you something like this, say Y is equal to X column, or you use what? Slash. S is between 5 and 20. How do you describe this? You say what? For instance, 6 is element of what? Y. Because as I said, S is describing from 5 to 20. You can also say 10 is element of Y. So know that this is what? Element. That means this value belongs to this set. That is that. Elements of what? A set. As I've explained before, the cardinality of a set is the number of distinct elements in the set. That could be represented as this. This is the cardinality of X. Like this is 1, 2, 3, 4. That is, we have 4 as the cardinality of what? X. Sometimes, some people use this to represent cardinality. That is the number of elements in X. Like here now, we can ask you to find the cardinality of Y. From 5 to 20, that is 16. The cardinality of Y is equal to 16. Or you say the cardinality of Y is equal to 16. So also know about cardinality, how to represent what? Cardinality. The next thing we need to look at now is union set. As part of set operation. What is a union set? The union of two or more sets is the combination of the elements of the set without repetition. For instance, if A is equal to 1, 2, 3, 4, 5, 6, 7, and B is equal to 5, 6, 8, 10, 11. The union set is represented as this union. Okay, if I say A union B, it means the element in this place and the element in this place, there shouldn't be any repetition. I have to write 1, 2, 3, 4, 5, 6, 7 for this. Now I want to write 5 again. No, 5 is already here. I want to write 6. No, 6 is already here. I want to write 8. 8 is not here. I write 8. 10 is not here. I write 10. 11 is not here. I write what? 11. This is A union B. As I said, the union of two or more sets is a combination of the elements of the set without repetition. It is denoted as this, that is union. I may ask you, for instance, list the elements of S union Y if S is equals to A, B, C, D and Y is equal to A, D, E, A, F. You agree with me that S union Y, pick all the elements here first, A, B, C, D. Then we come here now, A is already here, D is already here, E is not here, we put E, A is already here, F is not here, we put F. We take from here, I take from here, but there shouldn't be what? Any repetition. That's the meaning of union of two sets. Next is intersection. The intersection of two or more sets has a result of a set that contains only the common element in them. It is denoted as this. It's like the opposite of what? Union. Okay? This is not N, and also union is not U. No, we mean like this. Okay? Why this one is what? Like this. Okay, let's continue on intersect. For instance, I say X is equal to Peter, James, Anne. I say K is equal to Mike, Anne, Peter, and Kate. And I'm asked to find the intercept of S and K. It means the name that appear here are also appear here. That is, S intersect K is equal to Peter is here, Peter is here. James is here, James is not here. Anne is here, Anne is here. That is the intercept of these two sets. In other words, the thing that brings them together, the commonality, what is common among them, is called what? Intercept of two or more sets. If you want to use set notation for this, if A and B are two subsets, mathematically, A intersect B is equal to X, such that X is element of A and X is element of B. You agree? X is a set. As you can see in this place, this is element of K, that is Peter, and is element of K2. The same thing goes here. Peter is element of S, and is also element of X. A intersect B is such that S is element of A and X is element of B. The next is complement of set. The complement of any set is all the elements outside the set but within the universal set. How do I mean? If you are given that the universal set is equal to, say, 10, 20, 30, 40, 50, 60, then 70. And you are given that N is equal to 30, 50, 60, 70. All these are in N. What are those elements in the universal set but not in N? That is this, this, and this. Those words that are not in N, they are the complement of N. How do you represent that? Say n raised to power 1 or n raised to power c, which is equal to 10, 20, 40. Although it's a subset of this universal set, the remaining elements in the universal set that are not in n, they are called what? The complement of n. Disjoint set. Disjoint. Two sets, say A and B, are said to be disjoint when they have no element in common. A and B are said to be disjoint if they have no elements what in common. It means that A intersect B is equal to null. For instance, I say A is equal to 1, 3, 4. I say B is equal to 14, 17, 18. There is no element that is here that you will find here. Therefore, we say A and B, there is nothing connecting them together. There's no element in this place that is also in this place. So if you are asked to find A intersect B, you can easily tell that what is going to result to what? An empty set. You can't say 1 is here, 1 is not here, 4 is not here, 3 is not here, 14 is not here, 17 is not here, 18 is not in this place. Therefore, their interset is empty. Either you use empty curly bracket or you write this. Let's look at the non-disjoint set. Set A and B are said to be non-disjoint if they have at least one element in common. That means their interset is not equal to null. For instance, say A is equal to 1, 4, 7. I say B is equal to 4, 8, 10. You agree with me that at least they have one common interset. So A intercept B is equal to, okay? So this is what non-disjoint. Therefore, A intercept B is not equal to null. Let's see again how to use set builder to represent union, interset, and complement set. A union B, you can represent them as X, where S is element of A, or X is element of B. We have done this. For instance, if A is equals to A, B, C, D, and B is equals to C, D, B, K, you agree with me that A union B is equal to A, B, C, D, C is here, D is here, B is here, then K. Now look at this place now. If we look at here now, let's see S. These are S now, such that any of these is either element of A or element of B. A is element of A, correct, but not element of B. It's okay. At least it's element of one of them. B is element of B too, also here too. C is here too. Either element of A or element of B. What about if you want to say A intersect B? How do you use set builder? You use S is such that S is element of A and, remember the word and, S is element of B. That is direct like this for union or for interset and, okay. For complement, complement of say A is equal to all the elements outside A, but within the universal set. This X is not element of A, but is still within the universal set. For instance, A is equals to 1, 4, 5, and the universal set is equals to 1, 2, 3, 4, 5. So A complement is equals to 2 and 3. So these are the complement. As you can see, all these elements are not in this place. 2 is not here, 3 is not here. That is why we are saying S is not element of A. These guys, which is the complement of A, are not element of A. That's what this place is saying. Thank you for viewing. Let's look at the 7 laws of set. The first law is called the Idempotent Law. What is idempotent? Idempotent means a property of a certain operation in mathematics and computer science, whereby when you do operation on this object, it will continue to remain the same. Okay? It's like we have set A to be 1, 2, 3, 4. Irrespective of what you do to A, it will still remain the same. If you perform such operation and A still remain the same, such operation is following what? Idempotent law. Let me show you. A union A, you agree with me, is equals to A. A intersect A, you agree with me, is equals to A. This type of operation you perform here now, at the end of the day, you are still having A. We call it what? Idempotent law. Okay? That is the number one. Number two is associative law. Under associative law, we have this. If you have set A, you have set B, you have set C, B union C, union A, you're going to have what? A union B, union C. Look at it. It's just like rearrangement. If you perform this union first between B and C, before you use the result of this one to perform the union on A, you can still have the same result if you start with A and B first, then you use the result to do with C. Irrespective of how you arrange them, even though we have A, B, C, D, E, we are saying, if you like, do this one first, union this, union this. You now use the result of this one to perform union on this. You now use the result of all of them to perform union on this, even though you rearrange them the other way around, like this. You can decide to perform this one first, before you perform for this, before you can perform for all. You will still have the same result. This is called what? Associative law. As long as union is concerned, it doesn't matter who you start with. You are still going to head up what? With the same results. The same thing goes for intercept. A intersect B intersect C, A intersect B intersect C. You can decide to start with this one first before you come for C, or you start with these two first before you come for A. You're still going to have the same result. This is called what? Associative law. We also have what we call, number 3, the communicative law. This one is simply saying that A union B is equal to B union A, or A intersect B is equal to B intersect A. That is called what? Communicative law. The fourth one is distributive law. Distributive law is simply saying that if you have A, you have B, you have C. If you do B union C, then you apply intercept on A is equal to, if you do it as if you are multiplying, that is, if you say A, B plus C, for instance, you're going to have A times B plus A times C. The same thing you can apply here. You can simply do A intersect B, then you put the union A intersect C. Then you move these ones like this. Just the way you can still move these two like this. Okay? You understand this now? A intersect B union C simply means you can do these two, A and B, then you come back again and do A and C, then you put this union in between them. This is called what? Distributive law. Why distributive? Because you are distributing this A on each of them. A is distributed on B, you have this. A is distributed on C, you have C and A in this format. The same thing goes, if you have A here, you have B here, you have C here. Assume here we have union. Between this one we have intercept. The same distributive law says that you can do A union B. You also do A union C, two of them has what? Intercept in between them. You are distributing this one on this, then this on this, before you put this intercept between them. This is called what? Distributive law. Let's look at the fifth one now, which is the De Morgan's law. De Morgan's law. What is De Morgan's law? De Morgan's law is simply talking about complement. Remember we said that if you have a universal set that is 1, 2, 3, 4, 5 for instance, and you have A equal to 1, 4, 5, the complement of A is equal to the elements in the universal set that are not in A. That is 2 and 3. So 2 and 3 is the complement of A. You represent it like this. De Morgan's law is saying if you do A union B, the complement is equal to A complement, B complement, then opposite of this union, which is this. Or you have A intersect B complement. You can separate them, but you must put opposite of intersect, which is what? Union. Okay? Let's go for the next one, which is what? Complement law. Complement laws. It simply says if you have complement of A, then you apply another complement, you are going to have what? A. Let's see. This is universal set. We say it's equals to 1, 2, 3, 4, 5, 6, 7. Okay? Then we say A is equal to, let's say this time 2, 5, 7. The complement of A is equal to what? 1, 3, 4, 6. Complete. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Altogether correct. Okay? Now, it's saying if you apply a complement on this now, let's see. If I say this complement, that is the element in the universal set that are not here. That is the meaning of this now. I am applying complement on this A complement. That is double complement. What are the elements in the universal set that are not here? I agree with 1 is there, 2 is not there, 3 is here, okay, 4, 5, 6 is here, 7 is not here. As you can see, all these elements are also here. It means that what? The double complement of A is equals to A. That is the meaning of this. A complement, then the complement of that is equals to what? A. That is complement laws. Under the same complement law, for the union, we have A, for instance, union A complement is equal to the universal set, which you can represent like this. Or let's see, use the one we used before. Okay? A union complement A will give you the universal set. And if we look at this one too, you agree with me, if this is A and this is its complement, if you combine these two together, that is union, you are going to have what? The universal set, which is, okay? Same thing. Last but not the least is identity law. It says A union empty set is equal to A. Remember, empty set or not set is just nothing. It's like you say 2 plus 0. You have 2. 1 million plus 0. We still have 1 million. So the same thing, if you do union with empty set or not set, you're still going to have the other object, which is A. Also, other identity law, we say A union universal set, you're going to have what? Universal set. Of course, you agree with me. Let's go for A now. A union this universal set. You agree with me that we want to build a relationship where there is no repetition. If we go with this first, we now want to include A now. 2 is already here. 5 is already here. 7 is already here. It means that universal set union A is equals to universal set. We call it what? Identity law. Under this same identity law, if we look at the other side of it, which is the intercept, A intercept universal set is equal to A. If you investigate that also, you have the same thing. A intercept null set, you have null set. Of course, if this is A null set means there is nothing inside. So the intercept between this is not possible. You are still going to head up with what? Null. That is the meaning of this. This one, the same thing. The intercept of A and universal set, you agree with me, is what is in universal set that is also in A. Of course. At the end of the day, is everything A, you will have what in that what? Intercept between the universal set and A. That's the meaning of this. Everything A is what you will find when you want to intercept between A and the universal set. This is called what? The identity laws. Hope all these are well explained. Thank you for viewing. Now let's look at this challenge. If P and B are subset of U, which is universal set, which of the following is equivalent to P intercept the union of Q and E's complement? Look at this place very well. A union is complement is equals to the universal set. You know, we have established that. Let's check back. See? A union is complement is equal to universal set. So Q union is complement is equal to what? Is universal set. Therefore, we can easily say what? The new value we have from here now is equal to P intercept the universal set. The next one is P intercept universal set is equal to P, because when you do intercept with universal set, and if you are a subset of that universal set, definitely the result will be U. Therefore, this is equal to P. You can also check that P intercept is universal set. Let's see. A intercept universal set will give us what? A. The same thing goes that P intercept universal set will give us P. Therefore, the result is A. Okay? P is a non-empty set and null is an empty set. Which of the following is not true? Let's see. P union empty set definitely is P, because if you have a union with an empty set, that is, we want to pick element from P and empty set without repetition. At the end of the day, you will end up with element of P because this guy will never provide you any element. That is correct. P intercept null set or empty set, that is empty, of course, because in B we are saying what are the elements in P that you also find in null set? None. There's no intercept between them. They are totally what? Disjoint. C. P union P. That is, you want to pick element from P. I also pick from P, but no repetition. At the end of the day, you will end up with P. Definitely, this is actually the culprit. Let's check this. P intercept P. Definitely is P. And we have said the complement of a couplet of a set is equal to the set. Therefore, the answer is C. Hope this understood. Thank you for viewing. Let's look at finite set. These are sets that are countable. That means you can count them. For instance, you can count the number of states in America. You can count the number of cars in the parking lot. Okay? So if you have finite set, definitely we have infinite set. What is that? These are uncountable set, or countable. This is what? Countable. Okay? What are the uncountable set? For instance, all natural numbers. You can count them, but when are you going to finish counting them? For instance, the number of states in America will remain the same unless there is a change in the future, which is not foreseeable. But for this one, if I say D9 is equal to S, such that S is element of N, where N is what? Natural numbers. These natural numbers, you agree with me, they are what? All countable. Start from 1, 2, 3, 4, 5. When are you going to stop? Also, you agree with me that all integers are also what? All countable. So if I write something like this, say K is equal to S, such that S is elements of what? Integers. That is both negative and positive integer. You agree with me, they are what? From minus infinity to plus infinity. Okay? These are what? All countable. So you now know the difference between finite and infinite set. Let's look at range and domain sets. Range simply means the y-axis elements. Y domain simply means what? The s-axis elements. These s-axis elements, which are the domains, are the input needed by this function to produce the y-axis, which we call what? The range. Okay? So domains are all the values that goes into what? The function. Range are the values that comes out of the function. Let's see. So it's like this. The input comes in, which are the domains, into this engine. This engine works on the input to give what? Output. Okay? You agree with me that the function, which is y, that is range, depends on the x. So therefore, domain is the independent variable, while this range is the dependent variable, because range depends on domain to exist. So in essence, range is the difference between the lowest and the highest value. As you can see in this place, you agree with me that this is the lowest value and this is the highest value. So the difference between this lowest value and the highest value is what we call what? Range. That is, if you want to define range in isolation. For instance, if you are given this set of numbers, say 4, 7, 9, 1, 8. The range is 9 minus 1, which is equal to 8 for this set. Okay? So range is always the difference between the lowest and the highest values. And you agree with me that most of the time, S comes before Y, because S is the independent variable, and without S, we cannot have Y, which is the function that depends on the X. So you want to represent this with set builder notation. What do? Look at this. If I have these coordinates, say 2 to 4, 3 to 7, 5 to minus 6, 3 to 6, say minus 10 to minus 11, and so on and so forth. If I have something like this, these are set of what? Values. This first one represents what? The domains. These are the domains, which is the X. While these other ones are the what? The range, which is the Y. If you want to represent this, a domain, which is S, such that X is equal to 2, 3, 5, 3, minus 10. I'm referring to all these first ones. Then to represent the range, you say y such that y is equal to 4, 7, minus 6, 6, minus 10. So whenever you are given any set of number that involves both the domain and range, you can represent them like this with the set builder notation. You can also represent them formally like this. Draw this, you also draw this. This is for x, this is for y. Okay? That is for the domain and for the range. Then you put the dots. For instance, we want to represent this now. How many? 1, 2, 3, 4, 5. Okay? Just put 5 dots here. Each of the dots corresponding with the domain and the range. Then just link them together. Depends on the value. For instance, this one, we're going to write 2 and 4, right? I say, for instance, this is 2, this is 4. Then this second one is 3 and 7. I say, this is 3, this is 7. And so on and so forth. Just what? Map them together. This map. So every function has what? A domain. If you say, for instance, x plus y equals to 4, we are referring to the domain, we are referring to the range. Or you say 2x squared plus y equals to 0, for instance. The same thing. Every function has what? A domain. Because without the domain, you can't produce the range. Most of the time, inequality are employed to define the given set. How do I mean? You agree with me that if I have this, say 8 minus 4, we have 4. I can represent them like this to say, starting from 4, 5, 6, 7, 8. Okay? Even 9, 10, 11, 12. Here fall into what? 8 and 4. So we do this. We say this is a range. And 8 minus 4 will give us 4. And the set of numbers are 4, 5, 6, 7, 8. Okay? Now, how do you represent this with inequality? Inequality in the sense that either you use the straight inequality or you use what? Weak inequality. Let me show you how to represent them with inequality. It's a matter of putting x in between. You put this and this. So here now, s is less than what? S is less than 9. Here, s is less than 3. This is one method. Or you say, you put 8 here, you put 4 here. We call this one straight inequality. Straight inequality. Why this one is what? Weak inequality. Okay? Why are we calling this one straight inequality and this one weak inequality? Although they are speaking the same language, they will produce the same result. But why this one is called straight and this one is called weak? This straight inequality is that this boundary or the limit numbers will not appear in the result. As you can see, 4 and 8 are not here. So this is 3, this is 9. 3 and 9 are not part of this result. But here, we call it weak inequality because 4 and 8 are part of the result. Here means s is greater than or equals to 4. You agree now? This is 4 is as described here, or s is less than or equal to 8. This. But here, this is what? 100% inequality. We are not even equal at all. You agree with me? It's like you are arguing with somebody. You are telling the person that we are not equal in any way. You cannot appear in my category. You cannot appear in my level. Look at this guy. This guy cannot appear here at all. 3 cannot appear. 9 cannot appear. This is what well-defined inequality. There's no way 3 and 9 can ever appear inside X. Straight inequality. Here is weak inequality because the word inequality means things are not equal. Okay? If actually you are talking about inequality, things that are not equal, why are you bringing 4 and 8 that are part of this? This is weak inequality. You are saying less than or equal to. That is 50-50. Though you are getting it, it's 50-50. If I'm reading this without seeing this, I look at this, this is very weak. This one is very sharp, very straight. That's why we call this one straight, while this one is what? Weak inequality. For instance, you are given something like this, G is equal to S such that 1 is less than X and S is less than 5. What type of inequality is this? This is straight inequality because this and this will not appear in the output. We are going to have G is equal to 2, 3, 4. These two will not appear. But if I give you something like this saying L is equal to Y such that 14 y 20. This is what? Weak inequality, because these two guys are going to appear here. We can say L is equal to 14, 15, 16, 17, 18, 19, 20. So now that you know this, if you are given something like this now, X, when you see this type of double lines represent real numbers, not just ordinary arrow, okay? Then we go like this. See, for instance, N is less than or equal to X, and X is less than or equal to M. If I give you this now, with this inequality here, you agree with me that this is what? Weak inequality. It means that N and M will appear in the result. This one is K equal to this. They say reconstruct K. It means that what makes K are real numbers, and they start from N and hence in M. But what is in between, we cannot tell. Okay? The starting point is N, and the end point is what? M. Let's look at the general number sets. You agree with me, we have the complex number. Other complex number, we have what we call what? The imaginary numbers. On the other side of the complex numbers, we have the real numbers. Other these real numbers, we have irrational numbers and rational numbers. The rational number give birth to fractional what? Integer. Integer give birth to negative integers, zero integer, and what? Natural numbers. So here we have negative integer. We also have the zero integer. Then we have what? Here, the natural number. If you combine this and this, we have what? The whole numbers. Okay? So the complex number is represented by this, that is C, with a line like this. Okay? The real number are represented by arrow, but here will be double stroke. Okay? Like this. Double lines, then arrow. Irrational numbers are represented by I, but the line you're going to draw is going to be double. Irrational numbers. While rational numbers is represented by what? Q. Put two lines like this. The integers are represented by Z, but you must draw what? Another line like this. While the natural numbers represented by N, but this N you must draw double line like this. Remember that this whole group fall into the integer groups. We call what? Z. The other side of this rational number, which is fraction, sometimes call it what? This one. We sometimes call it what? Measuring numbers. Other these irrational numbers, we also have two other numbers. One is called what? The real algebraic numbers and transcendental numbers. Okay? So both these real algebraic numbers and transcendental numbers is referred to what? Irrational numbers. And remember that everything here, all this one you are seeing here, all of them put together like this are called what? The real numbers. This other side is what? The imaginary numbers. I mean, this side of it, all these ones put together are referred to as what? Real numbers, all these ones. If you want to represent the natural numbers, they are equal to S, such that S is equal to 1, 2, 3, 4, 5, 6, and so on and so forth. Okay? Then if you want to introduce a whole number, say whole numbers. Okay, let's say whole numbers. So that S is equal to, now you have to put this with 0. That is just the difference. You include 0. Okay? Once we put 0 to natural numbers, we say such numbers are what? Whole numbers. The way you want to consider now the negative numbers along with these whole numbers, you are not talking about what integer, which is represented by z like this. S such that s is equal to, from infinity, let's say minus 2, minus 1, 0, 1, 2, to infinity. These are called what? The integers. Okay? So all these ones is what we refer to as what? Rational numbers. Rational numbers. Okay? Everything here, we refer to them as what? That is both the natural, the whole number, and the integer. They are referred to as what? The rational numbers. Because these are rational, okay? Now when you now put in s equal to, you want to include like 1 over 2, 3 over 5, 6 over 7, 1 over 2, for instance, or 2.6, etc. All these numbers now, we call them what? The measuring numbers. Okay? So the measuring numbers plus the integers plus the whole numbers plus natural numbers are called what? The rational numbers. All these are called what? Rational numbers. And rational numbers are represented by what? Q, as I said, with these straight lines. I remember that the measuring number, another name for them is what? Fractions. You want to bring in the other numbers we call the real algebraic numbers. Real algebraic numbers, which you can represent like this. Real algebraic numbers. These are such that s is equals to square root of 2, for instance, minus square root of anything like 5 that will give you fraction, or things like 1 plus square root of 5 over 3, and so on and so forth. These ones are called what? The real algebraic numbers. And it also falls into the group of what? Irrational numbers. If you put all these numbers to exponential, pi, exponential raised to power pi, this is like linear function, that is natural logarithm 3, for instance, or you look at sine pi over 5, etc. All this type of number, we call them what? The transcendental numbers. They fall into what? The irrational numbers. Okay? All these ones. This one alone is called what? Transcendental numbers. Both this and this put together are referred to as what? Irrational numbers. Okay? For the imaginary side of the complex numbers, we have something like this: a plus b I. We say this one and this ones are the what? The real numbers. Why this guy is the what? The imaginary number. You have something like this: 2 plus 3i, or 1 over 2 minus square root of 5 over 2i, or you have minus 6i or pi I. All these are what? Complex what? Numbers. Okay? So that s is equal to all this, called what? The complex numbers. If the set U is equal to this element, describe the following by listing the method and state whether they are subset of U. Okay? The first thing we're going to do now, we're going to use quadratic equation. That is the method we're going to use to solve this one, to actually get the value of x. Once we get the value of s, we now confirm if they are in this place, if they are subset of U. Two numbers where you add together, you have minus 3, and if you multiply them, you have 2. Those are minus. You agree with me? This and this will give us this. If you multiply minus 2 and minus 1, you have plus 2. Okay? Then we can take this and this. We take one of these. I believe you know quadratic equation. So now we can say S is equal to 1 or S is equal to 2. Let's check here. We have 1 and 2 here. Therefore, A is a subset of U, which you write like this. A is a subset of U. It's a proper subset. You agree with me that with this dot, it means that what? We are going infinity. If you continue, you will reach 20. Here we have 20. 3 is here. 2 is here. Therefore, B is a subset of U. So for B is a subset of U. Hope this is understood. Thank you for viewing. The universal set and its subset A and B are described as below. This is the universal set. A are the even numbers between 20 and 35 because we said in this place that A and B are subset of U. B are the prime numbers between 20 and 35. The first thing we need to do is to get the universal set first, which are, remember, this is what? A strict inequality. It means this one cannot be included. So we have to start from 21. Okay. Therefore, A, all the even numbers between these guys. That is 22, 24, 26, 28, 30, 32, and 34. Lastly, all the prime numbers between these two. So B is equal to prime numbers, that is 23 and 31. We are asked to find A union B complement. How do you find this? A union B complement. To find this, we simply do the union. That is, all of them must appear in the union. Let's find the union first. Everything here and everything here. 22, 23, 24, 26, 28, 30, 31, and the complement of this, that is the numbers in universal set that are not here. Those are 21, 22 is here, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. That is all. Okay? So we are able to build all this from here. Then we find the complement of the union of A and B. Hope this is understood. Thank you for viewing. If A is equals to this and B is equals to this, find the elements of A intersect B. So the first thing we need to do now is to bring this out. Let's also bring this out. We can work on this by saying this 4 raised to the power 2. You agree with me, this base and this base are the same, this and this are the same. It therefore means that what? S is equals to 2. What am I saying? If I put this one side by side, the base are the same. It means that because these bases are the same, we can easily say S must be the same with this. This must be the same with this. Either way, S is equal to 2. Okay? What of Y? We cannot find 1 now by say here, for instance, Y raised to the power 2 because S is 2. So definitely, if the power are the same, the base will be the same. So Y is 4. Therefore, we can say here the elements of A are equal to 2 and 4 because we are told that is S and Y. And S is 2, Y is 4. B is also the same thing. So A intersect B is equal to same. Hope this is understood. Thank you for viewing. It says if the universal set is equal to this, A is equal to this, B is equal to this, and C is equal to this, what are set A, B, and C? Also find complement of A intersect complement of C. If you look at this 1 to 10, A are what? Even numbers. You can say A is what? Even set. Comma. What about B? B, these are odd numbers. You can say odd sets. What about C? C, these are prime numbers. Prime sets. Okay. What about this? The complement of A, that is, what is not here that is here? 1 is not there, 3 is not there, 5 is not there, 7 is not there, 9 is not there. What about the complement of C? What is not is C that is in the universal set? Let's see. That is 1, 3, 4, 6, 8, 9, 10. Now let's find this. What is here that is here? 1 is there. 3 is there. 9 is also there. Hope this is understood. Thank you for viewing. If P is equals to this and Q is equals to this, where S is element of real numbers, find P intersect Q. This is X, this is X. They are all real numbers. You need to get for P first. So therefore P is equal to, all these are included because this is a weak inequality. It's 1, 2, 3, 4, 5, 6. And Q is equal to, this is strict inequality. 2 and 9 will not be included. Now let's find the intercept. What is here that is here? 3 is here. 3 is here. 4 is here. 4 is here. 5 is here. 5 is here. 6 is here. 6 is here. Okay? Okay, look at this. It's a P is equals to this and Q is equals to this. Here, S is prime numbers, while here, S is odd. Evaluate this. This is what? Cardinality. As I said, when we treated cardinality, I said you can represent cardinality like this or like this. So both this and this are cardinality. The number of elements in this union and the number of elements in this intercept. So let's look at S here first to get P. Prime numbers between 2 and 60. 2, 3, 5, 7, 11, 13. Then for Q, odd numbers from 2 to 13. 3 is odd, 5 is odd, 7 is odd, 9 is odd, 11 is odd, and 13. We have to include 13 because this is weak what? Inequality. Now let's find this first. P union Q will give us all these elements should appear once here. 2 should go, 3 should go, 5 should go, 7 should go, 9 should go, 11 should go, then 13 should go. The cardinality of this is equals to 1, 2, 3, 4, 5, 6, 7. 7. Okay? Now let's also get this P intersect Q. What is here and also here? 3 is here, 3 is here, 5 is here, 5 is here, 7, 9 cannot go, 11 can go, 30 can also go. The cardinality, which can also be represented as equals to 1, 2, 3, 4, 5. Therefore, to get the two together, you see 7 plus 5, which is equal to 12. Find P intersect M intersect complement of G. Look at this. P intersect M is this place. P intersect M. That is 6 and what? 3. Use this one now to work with the complement of what? G. What are the complement of G? 3 is inside G. So the complement of G are 7, 6, and what? 11. So G complement is equals to this. 7, 6, 11. So the intercept between this and this is, what is here that is here? Is 6. Okay? 6 is the answer. Hope this is understood. Thank you for viewing. You are given this set U, P, Q, and R. We are asked to illustrate this in the form of Venn diagram and also to find the complement of P intersect Q intersect complement of R. Before we can continue, let's first of all get the elements. For this is a weak inequality. Okay? This is also weak inequality. Q is strict or weak, so we start from 2. Why this one is weak inequality? Okay? Now let's illustrate all these in the form of Venn diagram. So this is the universal set. We have all these ones are the subset of the universal set. What are we going to do? Let's put P here. Let's put Q here. Let's put arrow here. The first thing we must do is to find all the intersect. 1 is not intersect, 0 is not intersect, 2 is intersect. Because 2 is here, 2 is here, 2 is here. So that is the only intersect for 3 of them. 2 is out of it. The next one now is to look at between P and Q is 3 and 4. 3 is here, 3 is here, 4 is here, 4 is here. That is between P and Q. Between P and Q. Their intersect is what? 3 and 4. 1 is here, 1 is also here. That means between P and arrow is 1. P and arrow is 1. So 1 is gone, 1 is gone. What is remaining for arrow is 0. What is remaining for P? Nothing. And if you check very well, all the elements in the universal set are all represented here. 0, 1, 2, 3, 4. Okay? So the first one is done. We are asked to find the complement of P intersect Q. And the only complement of P is 0. Okay? Intersect Q. 0 intersect Q. There is no what? Connection. That is disjoint. What am I saying? The complement of P is equal to 0. That is this 0. Q is equal to 2, 3, 4. And the complement of arrow is 3 and 4. Although there's connection between these two, that is Q intersect R complement, that is 3 and 4. But here, if we find the intersect to these guys, there is no intersect. Therefore, the complement of these intersect Q intersect complement of this is a null set. Hope this is understood. Thank you for viewing. This is another Venn diagram. We are asked to find this. The first thing we need to do is to first of all find this. That is 1, 2, 3, 4, 5, 6. That is this, this, and this. Everything within X. Then Y complement is everything outside Y. This is Y. That is 1, 2, 6, and 9. Okay, the next one is Z complement, everything outside Z. That is 1, 3, 4, 6. 1, 3, 4, 6, 7. We are asked to find the intercept of all these. 1 is intercept, 2 is not, 3 is not, 4 is not, 6 is another one. So we can easily say S intersect complement of Y intersect complement of Z is equal to 1 and 6. A, B, and C are subset of the universal set U such that A are all even numbers, B are all odd numbers, C are all prime numbers, while U, the universal set, is from 1 to 20. We are asked to draw the Venn diagram and also to find all this. So the first thing we need to do now is to first of all bring out all these what? Elements for each of the sets. The C is equal to prime numbers. Okay, now we are asked to construct the Venn diagram. Let's do that. Let's look for the intercept. What we must take notice of is that these are what? Odd numbers. These are even numbers. There's no intercept between them. Okay, but between A and C, the intercept will be just 2. And between B and C, the intercept will be aside 1 and 2, every other thing. You see? Every other thing aside 1 and 2. That is the intercept. Between A and B, there's no intersection. So let's do that. So this is what I'm saying. Between A and C, I only see 2. What are the remaining elements for A? Every other thing. That is 4, 6, 8, 10, 12, 14, 16, 18, 20. Between B and C, we have 3, have 5, have 7, have 11, have 13, have 15, have 17, have 19. 2 is already here. This remaining one will be what? Put in this place. 9 is also here. 15 is not a prime. Sorry for that. 15 is not a prime number. 15 is not a prime number. So I have to put 15 here now. See? This is an odd number, but it's not a prime number. So we cannot put 15 in this place. So this one needs to go. Okay? And we are done for A. Everything we have done for everything. This is what? The Venn diagram. We are asked to find some set it is A intersect B. A intersect B. A intersect B. It's null because there's no intercept between A and B. We are also asked to find A union complement of B intersect C. A union complement of B. What is complement of B? That is everything outside B. That is every other thing here. All this. Okay? Now we need to find all these intersect C. All these intersect C. That is 2 at the end of the day. So this is going to be what? 2. B union C. B union C. That is all this. B union C. Okay? That is everything within this place. 1, 2, 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay? Hope this understood. Thank you for viewing. In this section, we're going to look at probability. So what is the meaning of probability? The first thing you should look at first is the word probability. That is probable. That is the likelihood of something is going to happen. We are talking about what? Uncertainty. The measurement of what? Uncertainty. And you agree with me that life is full of uncertainty. And every day we are confronted with what? Our ignorance. For instance, how do you know if rain is going to fall tomorrow? How do you know if your car will break down when you are going to the office? What is going to be the price of stock next week or next month? Who will win the upcoming election? These are the things we can tell what will happen next. So probability is a science of uncertainty. It provides us methods, rules, tools to deal with what? To deal with uncertainties. If I write this, Team A will probably win the football match against Team B. Or I write something like this. You will probably pass the exam. There are 40% chance this project will be finished on schedule. All these are what? Language of what? Uncertainties. We are not sure of what is going to happen. Okay? So you see things like chance. You see possibly. You see likely. You see success or failure. These what are the example of probability statement. Okay? We are going to look at a lot of instances and a lot of rules of probabilities to help us understand deeper everything you need to know to succeed with probability. General formula. The general formula in probability. The first thing you must put at the back of your mind is P. What is P? P means what? Probability distribution. Now, you threw what? A die. And the possible outcome are this. At the end of the day, it happened that 3 appeared. We agreed that 3 is called what? Event. This is called what? The sample space. We said that this is represented by either capital letter S or use the omega. And this one is represented by what? Capital letter E. The event here now is 3. What if you are given this type of question? And event A happened during an experiment. Okay? A is a subset of what? 3 possible outcomes. Okay? And these outcomes are what? Let's say omega. So we say what? A is a subset of the omega. Remember? Subset. That is, for this guy, for the coin, we have the possible outcomes are either head or tail. So H is an element of what? Omega. Or we say what? H is a subset of what? Omega. And omega is what? All the possible what? Outcomes. If you are asked now, in this type of scenario, to find the probability of A, you write probability of A. Okay? And one thing you must put at the back of your mind, the probability of A, the answer you eventually have, can never be less than 0 and it can never be what? Greater than 1. So, probability of A is always going to be equal to 0 or greater than 0. Put this at the back of your mind. Also, the probability of A will always be less than 1 or equal to 1. It means the probability of A is less than or equal to 1, greater than or equal to 0. It can never be less than 0, can never be more than 1. We say it is between 0 and 1. 4. If the probability of A is equal to 1, that is event A. This is what sure or set it to occur. That is, we are 100% sure after this calculation that this event A will definitely happen. Nothing will change it. However, if we do this and we have 0, it means it is impossible for this event to happen. If we have 100%, it will happen. Assume you are calculating probability that this guy will live or he will die, for instance, and you find that the probability of death is 1, that is 100% sure that this guy is going to die. And if the probability of death is 0, it means that what? It is impossible, he is not going to die. Okay, this is the language of what? Probability. With this, you are seeing here now, it means that what? It is what? Impossible to have what? A negative value for probability. Impossible. Can never what? Have what? A negative value. Can never be less than 0. Another point you must take note of is, for any event, the probability of success plus failure is always going to be equal to 1. That is, the probability of success plus that of failure is always going to be 1. Okay? So, if we are looking at A now, the probability of failure of A is this. Either you do this or some people do this. But I prefer to use this. A, then this at the top. That is equal to 1. Now the probability that A will happen, that the probability of success is equal to 1 minus probability of failure. Or the probability of failure is equal to 1 minus the probability of success. In general, probability of A is equal to the number of required outcomes all over the number of possible outcomes. Hope this is understood. Thank you for viewing. A ball is drawn randomly from a bag containing 8 red, 4 blue, and 2 green identical balls. Find the probability that the ball drawn is not red. 2 things you must put at the back of your mind. The first one is that we have told us that the probability of success plus the probability of failure is equal to 1. Now, they are telling us that what? The probability that the ball drawn is not red. Okay? The ball drawn is not red. That is, definitely, we're going to find that the ball drawn is red. That is success. Then we minus it from 1 to get for the failure. So the next thing is that what is the probability of success of what? Red ball. So the next you ask yourself, how many red balls? 8 red balls, 4 blue, 2 green. Total is equals to 14. Now, we have said that the number of required outcomes over the number of possible outcomes is equal to probability. How many required outcomes are here for the red to complete? 8 required what? Outcome. You may put it like this. Look at this as a battle between these groups. The red, the blue, and the green. It's a battle between this group. And if you want to go and fight, all the guys with red should go and fight. All the blue guys should go and fight. All the green guys should go and fight. Now, the red want to go and fight. So, all the 8 should go and fight. All over the total. You can't just say 1 over 14 because it was said that 1 ball was drawn. No. We know that it's 1 ball that was drawn. But everybody in the red group must come out to celebrate or to fight. Therefore, because red was measured at all, everybody here must go and represent. This will give us 4 over 7. We have to subtract it from 1. So this is the probability that what? The ball drawn is not red. Look at this. If Px denotes the probability that event S will occur, and Ps, this means what? Not. Or, can do it like this. Denotes the probability that event S will not occur. Which of the following is not true? We've established that probability can never be less than 0 or greater than 1. This one is correct. The same thing with this. It could be equal to 0 or greater than 0, less than 1 or equals to 1. This is also true. Success plus failure is equals to 1. Also true. This one says failure is less than 0. No. The probability that something will fail can never be less than 0. Probability that something will fail will definitely always be between 0 and 1. Probability that something will fail is greater than 0 but less than 1. Correct. So D is the culprit. Hope this is understood. Thank you for viewing. 50 balls in a bag are made up of red and blue balls. If 6 of the balls are red, how many red balls must be added to the bag so that the probability of red balls will be 2/3? Look at it. It's red versus blue. Okay, we have 6 red balls now. The remaining one should be 9. The total of 15. Okay, now currently the probability of red is 6/15, while the probability of blue is 9/15. But we are not interested in the blue. We are only interested in the red. But currently, if you calculate this probability, you agree with me, you're going to have 2/5. It's not the same thing with this. The question is now saying, if this probability is going to change to this, how many balls will you add to the red to make the probability change to 2/3? That is to say, let's call that X. S number of balls will be added into the bag to cause the probability to change to this. That is 6 plus X. If the number of red is increased, the total number of balls in the bag will definitely increase by this X. So this is the new probability now. This divided by this, which is equal to 2/3. But we don't know X. That is the work we need to do. If you cross multiply, you multiply this, you agree with me, you're going to have 3s minus 2s equals to 30 minus 18, which is s equal to 12. Okay? So this is the number of red balls that should be added to this bag to change the probability from 2/5 to 2/3. Hope this is understood. Thank you for viewing. Let P be the probability function on set X, where S is equals to A1, A2, A3, and A4. Find probability A1 if probability A2 is equals to 1/4, probability A3 is 1/5, and probability A4 is 1/6. Irrespective of the number of probabilities, the rule remains the same. We have PA1 plus PA2 plus PA3 plus PA4 as equal to 1. Okay? All the possible probability, when you add all of them together, they must amount to 1. They can never be more than 1. So we don't know this, we know this. As 1/4, this is 1/5, this is 1/6, equal to 1. Just find this. It's equal to 1 minus. Okay, before that, let's work on this. This is 60, the SCM. This place is going to have 15. This place is going to get 12. Here you're going to have 10, equals to 1. PA1. So if you continue, you add all this together, you're going to have what? 37. All over 60 equals to 1. So PA1 is equals to 1 minus 37 over 60. If you work on this now, 60 minus 37, which is equal to PA1, 23 over 60. So this is the probability of what? Of PA1. Find the total number of possible outcomes in a throw of 3 dice. Remember, if it was just 1 die with 6 faces, you're going to have 6 outcomes. That is the cardinality. 2, that is 6 multiplied by 6, which is 36. If it's going to be 3 dice, that is 6 times 6 times 6. That is 6 raised to the power 3, which is 216. This is the result. The total number of possible outcomes. Remember, we have done outcomes, right? We have done outcomes under the terms of probability. And we say what? It is the cardinality of what? Of all the possible what? Outcome, or the sample space. is equals to 2 and 6. If a perfect die is cast, what is the probability of obtaining a 5? What are the possible outcomes? Okay, that is what? 6. And you agree with me? 1 is just alone, 2 is alone, 3 is alone, 4 is alone, 5 is alone, 6 is alone. They are just 1 each. This question says, what is the probability of obtaining this 5? How many 5 are here? Just 1 5. Because that is a phase. The probability of obtaining 5 is equal to 1 over the total number of what? Possible what? Outcome. 1, 2, 3, 4, 5, 6. This is what? The result. A bar contains 9 identical balls, out of which 3 are blue, 2 are white, and the remaining are red. If a ball is drawn from the bag, what is the probability that it is blue? 2, not red. 9 altogether. 3 are blue, white, 2, red, 4. What is the probability that what is going to be blue? Remember what I said? Every guy here will go and what? Do the fight. So it's going to be 3 over everything, which is 9. This gives us what? 1 over 3. Probability is going to be what? Blue. What about the probability is going to be what? Red. That is going to be red. You agree with me it's going to be what? 4 over 9. But the question says not red. So probability that it's not going to be red, either you do this or you do this, is equal to 1 minus 4 over 9. Remember I said success plus failure is equals to 1. Now this is success. To get failure, you say 1 minus success. 1 minus success. So this is the success. We are removing from 1. So 9, 9, 4 equals to 5 over 9. Okay? So this is the probability that's what? It's not going to be red. Hope this is understood. Thank you for viewing. What is the probability of throwing an odd number with a fair die? Possible outcomes. How many odd? 1, 2, 3. These are the group of odd. These are the odds. These are what? The even. So it's a battle between odd and what? Even. Now, how many guys or how many numbers in this odd? There are 3 altogether. Sorry, not here. Okay? All together for the odd, probability that is going to be odd is everybody, not just 1. We know that we're going to choose 1 odd number. We know that if we throw the die, only 1 odd will show. But when there is issue, all the odd numbers on the die, as this is 1, this is 2, this is 3, this is 4, this is 5, this other side here, the front is 6. All the odd numbers will come out a fight. Not just 1 now. You can't say 1 over 6, no. All the odd numbers. That is called what? Number of odds on the die. That is this group of numbers. There are 3 altogether. All over total number, which is 6. So 1 over 2. Hope this is understood. Thank you for viewing. If today is Thursday, what is the probability that the next day will be Friday? Definitely, the next day is going to be what? Friday. To present this, you say the probability that the next day is going to be Friday is equal to 1. 100% certain. You are seeing it now? 100% sure that it's going to be what? 1. 1, 2, 3, 4, 5 to 17 are placed in a container and one number is drawn at random. What is the probability that the number is odd? I'm going to write all the possible outcomes. Okay, let's get all the odd numbers. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 odds. The total is what? 17. It says, what is the probability that the number drawn is odd? We are going to pick only one odd. It might be 9, it might be 13, it might be 3. But when you want to do the probability of odd, please note that everybody should be represented. And how many of them? There are 9. 9 over 17. That is what? The solution. Let's look at theoretical probability. What is theoretical probability? This is the probability calculated without the experiment being performed. Without what? Any experiment performed. So how do you get your data? You get your data by using only the available information about the physical situation. For instance, you know already that a coin has 2 sides, head and tail. These are available. You can use this one to do some studies. You also know that a die has 6 what? Faces. These are what? Available information. The kind of probability calculation you do without actually performing any what? Experiment. 2 numbers are chosen at random from 1, 3, and 6. Find the probability that the sum of the 2 is not odd. Look at these 3 numbers. This is based on theory. It's not actually what done. You look at the possible what? Output that might likely happen. This is what? Probability based on what? Theory. So we call it what? Theoretical probability. So how do you solve this type of problem? We are talking about what? Sum. You simply draw what? A table like this. You put 1 here, you put 3 here, you put 6 here. You put 1 here, you put 3 here, you put 6 here. Because we are talking about sum, You say this plus this will give you 2, this plus this will give you 4, this will give you 7, this will give you 4, this is 6, this is 9, this is 7, this is 9, this is 12. Remember they say 2, 2. That is, these are the possible what? Summation that will happen if you what? Look at all this. If you add all this together, either you add 6 and 6, you have this, 6 and 3, 1 and 3, it depends. So these are what? The possible what? Outcomes. Now, let's outline the odd numbers. This is odd, this is odd, this is odd, this is odd. Find the probability that the sum of the 2 is not odd. Either we use all this even, direct, or we use this odd and remove what? From 1. So you ask yourself, how many odd as per the summation? Remember, we are interested in what? In summation. That's why we did this. We are not interested in the individual numbers. We have 1, 2, 3, 4. 4 odds. Total 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So this is what? Odd. Probability of what? Odd. So probability of not odd is equal to 1 minus 4 over 9. You agree with me? This is 994, which is equal to 5 over 9. This is the answer. Find the probability that a number selected at random from 41 to 56 is a multiple of 9. And the first thing we need to do is to drop the sample space, which are these are all the possible numbers between 41 and what? 56. How many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 altogether. Or you can do it like this by saying 56 minus the first one, 41 plus 1. This will give us what? 15. Then plus 1, 16. Instead of counting manually. This minus this plus 1. Okay? That is just what? The outcomes. What are the what? Multiples of 9 here? That is 45. You divide 45 by 9, you have 5. Another number is 54. 54 divided by 9 will give you what? 6. 2 numbers are multiple of 9 between 41 and what? 56. How many of them? 2. That is 2 over 16. That is the probability that's what? Multiple of 9. We have 1 over 8. 2 fair dice Each of 6 faces, number from 1 to 6, are toast ones. Find the probability of getting a sum greater than 10. Remember, 2 fair dice. We are interested in the sum, not in the faces, not in this number. The sum of 2. Must go for the sum. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's add. This is what? 2, 3, 4, 5, 6, 7. This is what? 3, 4, 5, 6, 7, 8. Remember, we are adding like this. We go with this one now. This plus this will give us 4. This plus this will give us 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, 10. This is 6, 7, 8, 9, 10, 11. This is 7, 8, 9, 10, 11, 12. So these are the possible what? Sums. Okay. Now the question says, find the probability of getting a sum greater than 10. How many are greater than 10? Remember, strictly greater than 10, not less than 10, not equal to 10, greater than 10. They are just 3 in number. All together, how many of them? You agree with me, it's going to be 36 because the row are 36, the column are 36. 6 times 6 is equals to 36. And if you count them one after the other, you're going to have what? 36. It therefore means that the probability of getting sum greater than 10 is equal to 3 over 36 because there are 3 numbers. We have 1 over 12. If 2 fair coins are toast ones, what is the probability that at least a head is shown? 2 coin. At least mean what? Remember we said at least mean what? That is the minimum. It means it can be more than a head. See? 2 coins. That means it could be head, tail, or head, head. Remember at least. And there is no way you're going to throw 2 coins without having either head, tail, head, head, or tail, tail, or tail, head. It means therefore, we are going to put head, tail, head, tail. One coin, one coin. This is a possibility. Head, head, tail, head, head, tail, tail, tail. Okay? And they say what? At least. This is the word that gave me this idea. At least. One head. So we are interested in this at least one head. Could be more than that. At least. How many? At least 3. Altogether, how many? 4. That is to say, the probability of at least a head is equal to 3 over 4. 3 altogether 4. This is the answer. Hope this is understood. Thank you for viewing. 2 fair die are toast. What is the probability of not getting a total of 8? 2 fair die. Total. 2. Total. What is it telling us? Sum. It means the 2 fair die, we need to what? Add all the possibilities. Okay, let's do that. That the sum is 8 is all these ones. 1, 2, 3, 4, 5. So probability that the total is 8 is equal to how many? 1, 2, 3, 4, 5. 5 over 36. So the probability that total is not 8 is equal to 1 minus 5 over 36. That is the question, right? Not getting a total of 8. Have 36. 36 minus 5. You have 31 over 36. Hope this is understood. Thank you for viewing. A coin and a die are tossed up together once. What is the probability of a head and a 6 showing up? Head, a head, and a 6. A coin and a die. So 1, 2, 3, 4, 5, 6 for the die. And for the coin, we have what? Head and tail. So this combination will be H1, H2, H3, H4, H5, H6. This is one, T1, T2, T3, T4, T5, T6. These are all the possibility. How many altogether? 2 times 6, which is 12. Total of 12. If you count them manually, you have 12. Now, the question says a head and a 6. This is head and 6. Any other place we have head and 6? No. It means it's only 1. 1 over 12. The probability of what? A head and 6. Hope this is understood. Thank you for viewing. 2 fair coins are tossed once. The probability of getting at least one tail is what? At least mean could be more than 1. So head, tail. Remember, 2 fair coins. Head, tail. This is head, head. This is what? Head and tail. This one is what? Tail and head, tail and tail. This one says at least one tail. At least one tail, at least one tail, at least one tail. It could be more than one, but at least one tail. Altogether, how many of them? 3 for this possibility. But the outcome is what? 4. So this is the probability of at least tail.